Welcome back, ladies and gentlemen. In this video, we are going to talk about profit maximization in an optimization exercise. We're going to use linear programming to solve the maximization problem. Okay, so in this example, we have is a steel company that produces bands and coils. They can only produce one at a time. They cannot produce them both at the same time. And they have some limitations or they can and cannot do. Okay, so here we have some given information. Bands, they can do 200 tons per hour. Coils, 140 tons per hour. The profit per ton is $25 for bands, and for coils is $30 per ton. The maximum amount of tons they can produce of bands is 6,000. And the maximum, it's 4,000 for coils, 4,000 tons. So they have that limitation. And another limitation they have is that they have to keep that percentage relationship, 60% on bands and 40% in coils. The maximum production hours they have for the week is 40 hours. So let's see if we were to just quickly calculate with the numbers we have, what will be the profit? How many hours would it take if you maximize production? Typically, if you max all your production, then that will maximize your profits. But let's say we can fit it within the rules. So let's say they do produce the 6,000 tons of bands and 4,000 tons of coil. We do know the profit per ton there is $25. And the profit for a ton of coil is $30 each ton. So what will be the profit? We take the 6,000, we multiply by the $25, and we do the same if we do all the coils. And then you can add those two together. And we can also do that for this. All right. Now, so far, so good. Looks like we could maximize profits. However, let's check how many hours that would take. So if I produce 6,000 tons and it takes me 1 hour to produce 200, then I need to divide the 6,000 by the 200 to get the number that I need to get in hours. That would take me 30 hours to produce 6,000 tons. However, while we can get the number by dividing 6,000 divided by 200 to get how many hours it will take me to produce that, we're going to write it a little differently, because in linear programming, you always want to write everything linearly, not dividing by anything. So while it may seem like a necessary nuance, when you're dealing with other softwares that can do more complex scenarios, it's a lot better if you're not dividing and you always do everything in line. So the way to do it is, instead of dividing, we can multiply it by the reciprocal. So what we do is we can put an exponent of -1. And what that will do is the same as you were dividing, because the -1 is an exponent. We'll place that value under the value that you have on the left that you're multiplying. So it does some effect. While mathematically speaking is the same, computers deal with this a lot better than they would with the division. And you see, we still got the same 30 hours. So we want to do the same with this here. So we take the 4,000 and we're going to multiply it by the tons per hour, elevate it at the -1, so it does the same effect. So that will take 28.757 hours. So since we cannot do it at the same time, we're going to add them both together. Now we have a problem. 58.57 hours, which is more than the 40 hours. So another question is, how many of these should I produce to maximize my profits without exceeding the 40 hours. Now, just at this point, you would say, well, the one with the highest profit, just do that one all the way, and then whatever's left, do the rest. But we do have the percentage of production restriction as well. It has to be 60-40. So let's do the calculation. And there's a reason why I'm going to recalculate here again, instead of using the same numbers over here. And it'll make sense once we use the software in Excel, the solver, to get our maximum profit. So same fashion, we're not going to divide. We're going to go ahead and take the 6,000 tons, and we're going to multiply it by this number, which is the total, however, elevated to -1, so it does the same effect as dividing, so the 60%. Remember, we have to keep that 60-40, so we have to do that. Let's do that again with the 4,000 multiplied by the total at the -1. And that's our 40%. And just for good measure, we'll keep it like that. Now, the reason I did it individually is because if you have a situation with 4, 5, 6 products, then you will need to do one by one. Okay, so everything seems to be okay except the hours. So let's go ahead and set this up in a way that we can find what combination of production I should use to not break the 40 hours, keep the 60-40, and see how I can get the most out of this. So let's first identify the variables we can change. We cannot change the profit per ton. We cannot change the tons per hour, and the fixed production cannot be changed either. The only thing we can change is how many tons are we going to produce of each. So we got to identify those variables. I'm going to say bands, and let's just put tons there so we know we're talking about that. And let's call that X1. Let's say coils, and let's call that X2. Well, tons, and let's call that X2. Now, maximize. What we want to do is maximize the profit. Now, we know the profit is calculated by this times this, and then this times this, and then we add them together. So the way you would write it is max, the $25 that we have there, times X1. So bands is X1 now, plus the $30 profit that is being multiplied by the tons of coils, which is X2. And that's the idea. This times this, and this times this, then add it together. We want to maximize that. That's how you express that intent. So while we're there, let's go ahead and put X1 and X2 there so we know that's what we're talking about. Okay. Now, technically speaking, up to this point, we have not done anything different than what we have here. But now we need to talk about that 40-hour issue. And we need to talk about that 60-40% issue. And we need to talk about that we cannot exceed those tons. So we're going to start listing the constraints we have. Let's call it constraint 1. And we know that the bands have a maximum of 6,000, and bands is X1. So the way we'll write it is X1 has to be less or equal than 6,000. It cannot exceed that. So we're going to tell the computer that number cannot be more than 6,000. So what about C2? Okay, so let's talk about the maximum amount of tons allowed for coils. So same thing, but now we're saying that X2 are coils. The tons of coils cannot exceed 4,000. What else do we know? We know that there has to be that 60% production level for bands and 40% production level for coils. So we already spoke about how we wrote the formula that instead of dividing, we did the exponent thing. So X1 bands times the total production with a -1, so it creates that 60% like we did here, has to equal 0.6, not less than or greater than. It has to equal 0.6 of total production. So this formula here that we see here is representing what we did here. That same thing that we did there. It's just that we already used the total instead of adding them here. But for proper measure, we just write it as we go. And we'll do the same for X2. So coils, which is X2, cannot exceed the 40%. And again, that formula you see there is representing the same thing we have here, except that here we already had the total of both of them together with 10,000. All right. Now, so last but not least, our hours issue. Now, remember that you can get the hours it takes you to produce this by working with the tons per hour. So if we're not doing linear programming, remember that we can do the 6,000 divided by the 200, and that'll give me the 30 hours, the same you see here. But because we are doing linear programming, we're going to keep it all in one line, and that's what we have multiplied by that 200 at the -1 exponent. So we need to write that as such, that these two numbers, when you add them together, cannot pass the 40 hours. So how do we write that? Okay, so that'd be our fifth constraint. Let me go ahead and take that line out. That would be our fifth constraint, C5. And it will look like this. So let's expand that a little bit. So we have is this first piece here, X1 times 200 at the -1. That is the same formula you have in there. Then this next piece here is the same formula you have in there. X2 are coils multiplied by the tons per hour at the -1. And this 40 comes from here. So when you add them together, like we did here, they have to be 40 or less. All right. So this is just to get the data organized and make sure that we understand everything that's going on. We have covered all the constraints and limitations. Now we can use Solver to figure out the highest number we can achieve here while not breaking these rules. Go to Data, Solver, and let me go and clear it because I had it already. All right, so the objective is my profit, and I want to maximize it. You can always do like a minimum cost approach for different exercises, or you can say exactly a certain number that you must reach. In this case, we want to maximize the profit. So that is our objective. And this is what you see here. Now, because this piece is already set up in the Excel sheet, then there's no need to write the formula here. Okay, so which cells are we going to change? Well, we need to change these two cells. These are the ones that we need to find a combination of tons, X1, X2, to maximize that. And here, subject to the constraints. So we're going to start writing these here. So what does that look like? Let's start with adding. So first, we need to know that X1 cannot be more than 6,000. So this is X1 right here. So this has to be less or equal. See, you got less or equal than 6,000. So we're going to use this one here. That's our maximum amount. So that whatever number is going to be here has to be less or equal than this number here. So we're going to hit add to add the next one. Now, whatever number we get here has to be less or equal than 4,000. Oops. Whatever we get there, that's a cell reference, has to be less or equal than this constraint, the 4,000. And that satisfies this issue here. Let's add another constraint. Now, the next thing we want to do is a 60%. We already had the formula here. So we're saying this here has to be less or equal. You can write the 0.6, so we can just select this number here. Okay, and that takes care of that one there. Let's add another one. This cell here has to be less or equal. And let's correct that. And I'm going to correct a few things. It has to be equal. We're following the equal sign. It has to be equal to 40%. I'm going to go ahead and add the last one, and then I'm going to show you how to correct the previous one. So again, when we're doing the cell reference of the 40% M6, according to the constraint, it has to be equal to the 40% here. So whatever number goes here has to equal that. Let's go ahead and add the last one, where this one here, this total hours, this one has to be less or equal than the 40 hours that we have allotted, the maximum amount of hours. We're going to hit OK now. All right, so what happens here is that you're going to see the list of the constraints. But remember, a mistake was made on one of them, which was this one specifically. That's the one that is supposed to be the C3. And that one, we're going to go ahead and change it. And all we're going to do is we're saying that M5 has to be equal, not less or equal, to F5, which is the 60% here. Okay. So this number here, M5, go ahead and do it again. M5 has to be equal to F5. Doubled it up. Let's not do that. M5 equal to F5, which is this one here. And now we can hit OK. And that's how you fix it. Now we have it correctly done. So whenever you have something here that doesn't match what you want it to do, you can just highlight it and hit change. You can also delete them. You can always add more. So let's review. We have I5. This, whatever number is going to go there, has to be less or equal than E5, the 6,000 here. I6, whatever number goes here, has to be less or equal than E6, which is the 4,000 here. Excel is going to go ahead and change those for you to let you know the maximum profit you can achieve. L7. L7 is your hours. Your hours have to be less or equal than 40. You cannot exceed 40. That'll be D8. We're down here now. And this is the one we fixed. M5 has to be equal to F5, which is 60%. And last but not least, M6 has to be equal to F6, which is the number you have here. And the rest you can leave it the way it is. All you hit is going to hit solve. Now it's going to let you know that it found a solution and it's going to populate it for you. And then you get to keep it, restore the original values, go back, and you have the options. But if it worked, you just hit OK. So here's a solution. It's telling you that you want to produce 4,098 tons of bands and 2,732 tons of coils. And that will lead for the maximum profit possible. Now, and you see the 40 hours were met. You didn't exceed them, and the 60 and 40% was kept, the relationship. Now, I'm going to copy and paste this here so you see what the deal is. The point is that it's easier, we just do it up here. The point is that if I change any of these two values, you can increase this and decrease that or move it around. It's going to either lower your profit or break the 40-hour maximum or not keep the 60-40 relationship. And that's how you use Solver. Now, let's say that for any reason, I had to keep a 65-35 relationship. You can do Solver again. Let's say that changed. All you can do is go to Data, go to Solver, and since everything's already inputted the way you wanted it, 35, 65 is little numbers, you hit Solve, and it's going to give you the new combination with the profit maximization, and you kept the 65, 35%. And that's all to it. That will be the end of this video. See you on the next one.